Welcome to the workshop. I'm Bill, and today I want to talk about Coleman lanterns, specifically gasoline lanterns, and more specifically Coleman's Instant-Lite lanterns, and to talk about their theory of operation. Basically means how they work. Theory of operation is important, particularly when you do troubleshooting. If your lantern has a problem, you need to isolate where the problem is coming from, what's causing it. And if you understand how they work from top to bottom, it'll go a long way towards helping you isolate the problem. It'll be much less frustrating. So today we're going to do the work using this Model 200. These are very common. In the US, they were made from 1950 to 1983. In Canada, from 1951 to 1970. A lot of them out there. They're very representative of the Instant-Lite family. Now, this is a 1953 model made in Toronto. So we'll start at the beginning. Of course, what do you need for combustion? Because that's what we're working toward, is a flame that makes that mantle glow. You need two things. You need fuel and you need oxygen. So we'll start with fuel. No brainer, you already know this, I'm sure. The fount holds the fuel. Unscrew this fuel cap. It's sealed with a rubber gasket. You pour the fuel in there. You always want to filter your fuel just in case there are any impurities. Those impurities can be carried through the system and end up making a mess of things, clogging things up. So you pour your fuel in there. One of the first things you'll notice is that you can only fill the fount about 3/4 full. You can't fill it past this fuel intake. There's a reason for that. So fuel won't come out of the fount on its own. It needs pressure. You need to fill the top of this with air. So there's a cavity here that's filled with air, and then you need to pressurize air, which means pumping more into it. And of course, this is probably familiar to you too. You've got the pump, turn it anti-clockwise a couple of turns to open up the valve. You pump, put your thumb over the hole and you pump a few times to pump the air in there, and then when you're done, you turn it clockwise to close it off, and you're ready to go. Now you open the valve and the lantern's ready to light. But what's going on inside this pump? This is a common place for a lot of common problems. So let's look inside. Let's pretend we pull this off and look down there. To do that, let's look at this other 200. This one's already been partially disassembled. We'll take the vent off, we'll take the burner off for later. We'll leave the fuel supply components in place. If we were to take this off, you'd see a hole just like this. And this hole runs down into the fount. It's a little bit longer than your finger. It runs down here. At the bottom, you'll find a check valve that's very tightly threaded in place. You'll need a special tool to remove this. Don't just stick a screwdriver down there and try to take it out. Chances are you'll probably destroy the slot on the check valve. Use the proper tool. That'll be another video. This check valve sits down on the very bottom of it, and then on the back of the check valve, on the back of this tube, imagine the tube sticking down at an angle like this, there's a small little tube that runs straight up. What it does is the air goes down this tube, it goes into that little air tube, and then is delivered directly to the top of the fount. This keeps fuel from leaking back up the check valve. It seals this pump tube off from the fuel. So back to the check valve. This sits in the bottom. And there's an air stem. This is that thing you've seen if you do happen to pull the pump out, you'll see a little square rod down in here in the tube. That's the air stem. The air stem is threaded and has a pointed tip that mates with the check valve. This is what you're opening and closing when you turn it anti-clockwise and clockwise to open and close it so that it'll receive air. So this fits down inside. Now what slides over the air stem is the pump itself. You'll see it's hollow. That's why you've got to put your thumb over the top so that the air doesn't rush out when you push it down. The air stem just slides right inside, and you'll see the bottom of the pump tube is crimped, so it sort of makes a square inside there, and that's what turns the air stem. Turn it anti-clockwise to open it. Now air can go into the valve. Turn it clockwise to seal it back up and to close it. Now I should say, inside the check valve, there are two things here to keep air from coming back out of the fount when you pump it in. The check valve itself has a little ball bearing inside, and sometimes they get seized up. If you shake it, you probably can't hear it here, but I can hear it. That ball bearing shakes around. If it's moving freely, that's good. The air stem also screws down in there, and that pointed tip mates tightly, and it should seal it up. But the important part of this is the pump. And the most important part of the pump is this leather cup on the bottom. And normally, this one's brand new, so it's dry as a bone, but normally this would be saturated with oil. And the reason for that, one, it keeps this nice and flexible, keeps it from drying out, but it also keeps it so that it seals nicely to the pump tube. So when you push it down, the pressure behind it sort of pushes it out, it seals against the sides of the tube, and you can force the air down through the check valve and into the fount. Then, when you draw it back up on the upstroke, it compresses just a little bit, and it allows air to rush in around it and fill the void. You then, on the downstroke, push that air down into the fount. Of course, you need to put your thumb over the top so it doesn't escape up through the tube. So that's how the pump works. So we'll come back to our functional lantern here. 30 pumps will about do it on a full fount. You may need to put in a little more if it's empty or if it's getting empty. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Seal it off. Now, we've got a fount full of fuel, and we've got compressed air above the fuel sitting in the fount. What do we do now? Well, this is the point where we open the valve. And this is where we need to talk about the Instant-Lite circuit that is used to light these without flaring up. When I was a kid, I remember seeing these and wondering, it says open 1/4 turn to light, and then it says after mantles burn brightly, open as far as possible. I always wondered what the deal was with that. What's with the 1/4 turn? What's happening there? So in order to understand that, let's bring this lantern back and let's remove these fuel system components that you normally wouldn't see. Normally the valve is hidden inside the collar and the fuel pickup system is hidden down inside the fount where you can't see it. So there are 3 major components here. There's the fuel pickup, which on an Instant-Lite is called a fuel and air tube. There's the valve, the main valve body, and then there's a generator. And we'll look at each of these in turn. The fuel pickup first, the fuel and air tube. Now, on earlier lanterns and on kerosene lanterns, this is just a plain tube, and it's just completely open at the bottom. So if you unscrew the valve and open it, you open the valve, it allows the pressure in the fount to push the fuel runs straight up and into the generator. Now, if you do that with this lantern, well, if you do it with those lanterns too, without the generator being heated, you'll end up with liquid fuel coming out the tip. It'll run down, you'll have a fireball. You can ask my wife about that, especially on a dining room table. You don't want a fireball in your house. So, Coleman came up with this brilliant idea. Before this, you'd have to preheat the generator somehow. But with the Instant-Lite circuit, they've made a way to supply fuel to the generator, but not enough fuel for it to flood. And the way that works is with this fuel and air tube. It's actually 2 tubes. There's an outer tube and an inner tube. And you can see that inner tube if you look through this air hole in the top. The inner tube is open at the bottom. So air can flow down the outer tube and then back up the inner tube and into the valve. The fuel pickup is this little tiny hole down on the bottom. Now, as I said, if you just open the valve, and if this were like other earlier lanterns, fuel would rush in that hole up through the valve and you'd have a fireball. So Coleman had this brilliant idea. You've got a tube within a tube and this air wire that runs down inside, and if you push it down, it pokes through that fuel pickup hole in the bottom. Normally it doesn't poke out this much, but I'm pushing it all the way down just so you can see it. what happens is that almost but not quite plugs the fuel pickup hole. Because it doesn't quite fill it, some fuel will seep around it, just a little bit, and will seep down into the bottom of this tube. So what happens, this air wire is held down in place. Imagine my finger is the valve stem. It's held down in place when the valve stem is closed. If you open the valve stem a quarter turn, that's not enough to back it all the way out. Once the valve stem is backed out, the air wire pops up, and you can see the hole is now open. But with it open at a quarter turn, you've now got to place a release for the pressure inside the fount, so that air wants somewhere to go. And it starts pushing the fuel down. The fuel has very little room to move, so instead, the air escapes through this hole in the top. The air rushes down the outer tube, it picks up that little bit of fuel down at the bottom, and as it rushes back up the inner tube to the valve, that fuel forms droplets carried by that rush of air. That air then enters the valve, moves through the valve, and hits the generator. At the top of the generator is a gas jet. It's a tiny little hole. Depending on the model, it's anywhere from 5 to 9 thousandths of an inch. And the fuel comes out there. Now these little tiny droplets that are formed by the Instant-Lite circuit when this is shut off or when this is plugged aren't enough to cause a big fireball. But they are enough to produce some flame that goes up through the burner tube and causes enough flare-up, a small flare-up, that will relatively quickly, say within 5 to 15 seconds, heat the generator up to that needed 98 degrees Celsius, and then the gas will start vaporizing. So that's the beauty of the Instant-Lite circuit. You don't need to preheat the generator. You can just open it up and light it without the fireball. I said the other component that we need for combustion is air. So we've got the fuel now. Where do we get the air? Well, let's look at the burner. The burner has what's called an air tube. It picks up air down here from a hole in the bottom. This is sort of hidden inside the collar, so it's hard to see when it's all assembled. But air is drawn up here, and there's a little hole here, which is where the generator mates with it. If we put it together, the generator enters right here. So now, as gas vapor enters this mixing chamber, mixes with air, it flows through a venturi and around through this loop where they mix together and comes out at the burner cap as a jet of flame. Model 200 has one burner tube. You'll notice that's not always the case. This Model 242, which was the 200's predecessor, it has 2 air tubes, and it's got a different style of manifold or mixing chamber. The generator mates with it over here, the gas flows up and down, and as it does, it draws air in from the sides, and they mix and meet at the cap there. And then this 335, which in Canada was the replacement for the Model 200, very similar to this, although they used a stamped steel burner assembly. 2 air tubes coming up the sides, generator mates here, the gas flows up around through this mixing chamber and it draws in air with it as it goes through. The 220s and 228s, which we don't have here, another very common model, they just have 1 air tube as well. And you'll notice most of the Coleman lamps, the table lamps, only have 1 air tube. As long as it gets enough air, it's fine. So, at the burner, you should get a jet of flame at this point. Now that you've got fuel and air mixed, you get the flame. And that flame creates heat. That heat illuminates the mantle which ties on here. And the mantle is one of these. You can see it on these lanterns. Once they're burned in, they shrink up. The mantle doesn't actually burn once you pre-burn it. What these are, this is an old one that's made of silk. Coleman called them silk lights. It's a silk mesh, and it's impregnated with metal dioxide. When you pre-burn it, the silk, or later they were made of rayon, that silk or rayon matrix burns off, it shrivels up, but what's left behind is this rigid but a very fragile matrix of metal oxide. And it's that metal oxide that, in response to the heat from the jet of flame, begins to glow. These older mantles were usually brighter and whiter. The key component in them was thorium dioxide. Thorium is radioactive. So they don't use that anymore. It wasn't a problem for end users like you and I, but the people who worked in the factories, for them it was a legitimate health concern. So they switched and now use a mineral called yttrium. It's not quite as bright, but it gets the job done pretty well. There are different size mantles, depending on what size flame you have here. You need to have a mantle the appropriate size for the flame. On Model 200s, these were designed for a mid-size mantle. It was called a number 99. Those are getting more difficult to find. So a number 21 works quite well on these and is pretty much as bright as a 99. But one of the issues is the mantle sits alongside the generator and helps retain heat and keeps the generator hot. So it's important on 200s in particular that when you run them or when you light them and run them, you need to have the globe and the vent on them to retain the heat. Otherwise they'll get into the cycle where the generator will cool down a little bit and then it'll heat back up, and when it cools down you get a big flare out of it. So put the globe and the vent on when you're running these things. Now, one other thing that we need to talk about before we go any further, or before we wrap up, is cleaning the generator. There's one built-in troubleshooting thing that we should look at. You've seen this lever on the back of the valve. It turns around. It's got a little bent wire inside, and that wire turns an eccentric block, and you can see it move up and down here. Attached to that eccentric block is a cleaning needle. Let's look at the generator when it's removed. It's got a flared base and a tapered nut so that it seals tightly. You need to have this nut nice and tight so there's no leak, because this is going to build up pressure inside. Inside of the generator, you'll find a cardboard tube, the cleaning needle, and on these a steel spring. Some older generators, instead of cardboard, believe it or not, the cardboard won't burn, but on some of the older ones, they'll have a tube made out of asbestos braid. On kerosene lanterns, instead of a steel spring like this, they'll have a large brass spring, and then on most of them an even larger brass spring surrounding that. These help control the heat and the flow of fuel, but probably the most important thing they do is keep this cleaning needle centered. And that's important because remember that gas jet at the top of the generator. The hole is measured in thousandths of an inch. So that means this needle, which pokes through it from the inside, is even smaller. It's very fragile, it's very easily bent if this gets off center. So this slides up inside, and the hook on the bottom of the cleaning rod meshes with that eccentric block. And as the eccentric block goes up and down, so does that cleaning rod. What happens is the generator ends up with a lot of carbon inside as it's used. Sometimes you get impurities in your fuel. Those can flow up and they'll get stuck in the jet. Sometimes bits of carbon on the cardboard or inside of the tube or that spring will break loose. They'll get stuck inside the jet. Sometimes the jet itself simply gets some carbon buildup in it. That cleaning needle moves up and down through the generator and it will clean out the tip, at least most of the time. Sometimes you'll have to take the generator off, remove the tip and flush it out. But most of the time during ordinary operation, turning this cleaning lever a couple of times will clean out whatever the problem is, and it'll restore full brightness to your lamp. So, that's how they work. So let's get back to this. We've pumped it up. It's ready to light. Now before we light it, it can take a while for the fuel vapor, especially with the Instant-Lite circuit. It can take a while for those fuel droplets to make their way to the generator. Especially if the fount has been dry or the fuel system has been dry, there's a fair bit of space for those little droplets to get through. So when you're lighting it, it can often be helpful to turn the valve a quarter of a turn, just briefly, and listen. And keep it open and listen until you hear a sputtering sound. That sputtering sound will tell you that those fuel droplets have made it to the generator. So we'll do that first before lighting a match. And this time we heard that sputtering right away. So light a match. Now another tip, you may find on a lot of lanterns a lot of charring and black around these lighting holes in the base. If you want to avoid that, that's caused by the sulfur burning off on the match. If you want to avoid that, let your match burn for a few seconds before you insert it in the hole. Let this sulfur burn off on the top. So light the match, put it through the hole, a quarter turn. That's just how it should work. See, it's flaring just a little bit, but it's not flaring that much. And when it's done flaring, see it's turning blue, and you're hearing it roar. Now it's burning, and you can open it up all the way. If you need to, if it took a while to get that fuel out, you've lost some air in the top of the fount, you can unscrew this, add a few more pumps to replace the lost pressure in the fount. If it starts to get dim, you can turn the cleaning needle, and that'll clear out the top. So there you go. A Model 200 Coleman Instant-Lite. That's how it works, and I hope this helps you with your troubleshooting. We'll do another video with the lantern models that require preheating, that don't have the Instant-Lite circuit, but I hope this is useful for now. Thanks for watching.